Hello everyone, my greetings to one and all. This is the third session on determination of income and employment. In the previous two sessions, you have understood the basic tenets of Keynesian theory and consumption function. I am Poonam Vohra from Macroeconomics Learning Center. In this session, you will understand savings function. Savings is a counterpart of consumption, as whatever income is earned is either consumed or saved. So, to know more about savings function, let's begin. Savings function shows a functional relationship between income and savings. That is, savings is that part of income which is not consumed. Algebraically, S is equal to Y minus C, where Y is income, C is consumption, and S, savings, is a function of disposable income. Now, if savings are the difference of consumption and income, and consumption is written as C bar plus BY, where C bar is autonomous consumption and B is marginal propensity to consume or slope, then savings is equal to Y minus substituting C, which is C bar minus BY. So we get the algebraic equation as S is equal to minus C bar plus 1 minus B into Y. Why is it so? Simply because if C bar is autonomous consumption, then minus C bar is dis savings. And if B is marginal propensity to consume, then 1 minus B would be marginal propensity to save. One can then conclude if autonomous consumption is positive, then autonomous consumption is negative too, implying that autonomous consumption is equal to dis savings at zero income. Let's understand these aspects with the help of a table as well as diagram. Now, when income is 0, consumption is 20. That means at zero income, whatever expenditure has incurred has been possible by using the past savings. So savings gets reduced by the same amount, or we say dis savings are minus 20. It supports the fact that C bar is positive, therefore C bar is negative. When income is 40, consumption is more than income, then minus 10. That is, the difference between the two is dis savings. Similarly, one can find savings in each case by applying this formula, that is S is equal to Y minus C. The same can be shown diagrammatically. X-axis, income is taken. On y-axis, consumption and savings are taken, and by plotting these points, one finds savings curve which is beginning from some negative value that is below the axis. In this case, it is minus 20, and then it rises. It is upward sloping, which is supported by the numerical example. One can also observe that when income is 80, consumption is also 80. In that case, savings is 0. And this is the point of break even, where savings are 0. Thereafter, savings increase. So one can conclude that when income is 0, savings are negative. When income is same as consumption, savings are 0. And thereafter, as income increases, consumption also increases, savings also increase. So one can conclude that savings are negative when income is zero. Slope implies positive relationship between income and savings. Break-even point is when income and consumption are same or when savings are equal to zero. And after break-even point, savings are positive. There are two attributes to savings function, that is average propensity to save and marginal propensity to save, where average propensity to save is the ratio of savings to the corresponding level of income, that is S by Y. If savings is 30 at income 100, then APS would be 0.30 or 30% of income is saved. Now let's understand this with the help of the small table. When income is 0, savings is minus 40, APS cannot be defined. When income is 100, savings is minus 20, APS would be S by Y, minus 20 by 100, that is minus 0.20. Similarly, when income is 200, savings are 0, obviously APS will be 0. So with income 300, savings being 20, APS would be 20 by 300, which is 0.067. So is the case with income being 400, savings 40, APS would be 0.10. This can be shown diagrammatically too. We have already learnt how to make the savings curve. Here one can find average propensity to save at any point on the curve. So let us take point B. Corresponding to point B, one can find a point on savings, which is OA in this case, and on income, which is OM in this case. So average propensity to save at point B would be OA divided by OM. So one can have observations on the basis of this numerical example that APS can never be 1 or more than 1. It implies that savings can never be equal to or more than 1. Obviously, consumption has to take place. So whatever is earned, it's not that 100% is saved. Neither it can be more than that. But APS can be 0 as it is the break-even point, because this will happen when consumption is same as income earned. APS can be negative or less than 1, then that is dis-savings. And finally, APS rises with rise in income, simply because the proportion of income saved goes on increasing. Marginal propensity to save. It is the ratio of change in savings due to change in income and is written as delta S by delta Y. Let's have a look at the table. Here income is increasing by 100 in each case. Savings is also increasing with increase in income by 20 in each case. One can find marginal propensity to save in each case by applying delta S by delta Y, except for the case when income is 0. So one finds delta S is 20, delta Y is 100. It is 0.20 in each case. It means that 20% of the incremental income is saved. One can find marginal propensity to save diagrammatically also. For that, you need to draw the savings curve and take any 2 points on the curve. Here 2 points taken are point B and point A. At point B, income is OH, savings OK. At point A, income is OJ and savings OR. So marginal propensity to save would be delta S. Delta S is KR, whereas delta Y is HJ. So marginal propensity to save at point A with respect to B is KR divided by HJ. One can also observe that marginal propensity to save varies between 0 and 1. It is equal to 1 when entire additional income is saved. It is equal to 0 when entire additional income is consumed. Now assess yourself and identify the correct answer. Options are: marginal propensity to save is A. The proportion of total additional planned savings to total additional income. B. The proportion of total additional income to total additional planned savings. C. The fraction of additional income that is used for consumption. D. The fraction of additional income that is used for savings. Please check your answer. The correct answer is option A. Marginal propensity to save is the proportion of total additional planned savings to total additional income. Now that we have understood that income earned is either consumed or saved, we have also understood the meaning of average and marginal propensities to consume as well as to save. So one can then establish the relationship between these. Let's begin. We know that Y is equal to C plus S, consumption plus savings. Accordingly, if we talk of consumption, it is average propensity to consume and marginal propensity to consume. If we talk of savings, it is average propensity to save and it is marginal propensity to save. We have understood this aspect. Now we need to establish that APC and MPC are related to APS and MPS. How are they related? Going by this equation, if we talk of average propensities, it is average propensity to consume and average propensity to save is equal to 1. This can be proved by simple algebraic expression. This is known to us. So dividing by y on both sides, you get 1 is equal to APC plus APS. Hence, we have this relationship that APS is equal to 1 minus APC and APC is equal to 1 minus APS. So is the case with marginal propensities. Now, marginal propensity to consume plus marginal propensity to save is equal to 1. How is that? We know that if Y is equal to C plus S, obviously delta Y is equal to delta C plus delta S. Dividing by delta Y on both sides, we get 1 is equal to MPC plus MPS, or MPS is equal to 1 minus MPC and MPC is equal to 1 minus MPS. Simple logical deduction, and one can establish this relationship between average propensity to consume and save equivalent to 1 and marginal propensity to consume and save also equivalent to 1. Identify the correct answer. Out of the following, which can have a value more than 1? A. Marginal propensity to consume. B. Marginal propensity to save. C. Average propensity to consume. Or D. Average propensity to save. The correct answer is option C. It is average propensity to consume that can have value more than 1. Whatever has been understood till now can be verified through a numerical example given in the schedule. Here, income is given, consumption is given. Rest can be found. So let us begin. Income has been increasing by 100 in each case. Consumption has been increasing by 90 in each case. So one can find savings. Savings would be y minus c, 0 minus 20, 100 minus 110, 0 minus 20, 100 minus 110, 200 minus 200 and so on. 300 minus 290 and so on. One can find delta C. When income is 0, it is not defined. After that, it is 110 minus 20, which is 90. 200 minus 110, which is 90. 290 minus 200, which is 90, and so on. One finds that delta C is same in each case because consumption is changing at the same rate. One can find delta S also. Delta S is not defined when income is 0. After that, it is minus 10 by minus 20, 10. 0 and minus 10, 10. 10 and minus 0, 10. Similarly, one can find that delta S is 10 in each case. Also, delta C plus delta S needs to be equal to 1. So, one can verify it in each case. It is easy to find average propensity to consume, which is C by Y. So one can find 20 by 0 not defined. 110 by 100, 1.10. 200 by 200, 1. 290 by 300, 0.97. 380 by 400, 0.95 and so on. Similarly, one can find average propensity to save, which is S by Y. That is, in the first case, it is not defined because it is minus 20 by 0. Then it is 10 by 100. Minus 0.10. Then it is 0 by 200. It is 0. Then it is 10 by 300. You have 0.3. Then it is 20 by 400, 0.5 and so on. One can also find MPC. MPC is delta C by delta Y. Delta Y is 100 in each case. Delta C is 90 in each case. So it will be 90 by 100 in each case. And you get 0.90 in each case. So marginal propensity to save will then be delta S by delta Y, which is 10 by 100 in each case. So one gets 0.10 in each case. This also established the relationship that MPC plus MPS is equal to 1. One can establish that in each case. So with this numerical example, all the relationships can be verified. Consumption, savings and income can be shown diagrammatically too, either through one diagram or two different diagrams. For simplicity and for clarity, here two diagrams have been drawn. In both the cases, income is taken on x-axis, consumption on y-axis in the first diagram, and savings on y-axis in the derived diagram, as savings can be derived from consumption. 45-degree line is drawn, which represents income also. It has been already understood that when income is 0, consumption is some positive value which is represented by point K in this case. So when income is 0, that means by the same amount there is decline in savings or dis-savings represented by K here also. This is called autonomous consumption in the case of consumption and dis-savings in the case of savings. Then as income increases, consumption also increases, but by less than proportionate amount. One can observe that slope of the consumption curve remains the same, represented by marginal propensity to consume. Similarly, since savings is the counterpart of consumption, savings also increase. Slope of the savings curve also remains the same, represented by marginal propensity to save. So consumption and savings are upward sloping curves. In the case of consumption, it intersects income at a point where consumption is equal to income, point E. Correspondingly, one finds that on the savings curve also, savings are equal to income, that is where savings are 0. So it establishes the fact that when whatever income is earned, whole of it is consumed, C is equal to Y, then nothing can be saved or savings are 0. To the left of point E, consumption is greater than income and there is dis-savings in terms of savings function. And beyond point E, on the consumption function, consumption is less than savings and hence there are positive savings. So it establishes the relationship between consumption, savings and income. Now fill up the blanks with the appropriate terms. The value of dash can never be negative, while dash can have value equal to 1. Options are A. APS and APC, B. MPC and APS, C. APC and APS, or D. MPS and APC. The correct answer is option D. The value of MPS can never be negative, while APC can have value equal to 1. Now have a look at this question and identify the correct answer. If C is equal to 100 plus 0.75Y, where C is consumption and Y is income, then savings function will be expressed as A. S is equal to 100 plus 0.25Y, B. S is equal to 75 plus 0.25Y, C. S is equal to minus 100 plus 0.25Y, or D. S is equal to minus 100 plus 0.75Y. The correct answer is option C. That is, if C is equal to 100 plus 0.75Y, then S will be equal to minus 100 plus 0.25Y, simply because saving is a counterpart of consumption. I hope you have understood the concept of savings function in the tabular form as well as in the diagrammatic form. You have also solved few questions, though they are not enough, but at least they have made a base for you to solve other questions. With this, the session comes to an end. We shall continue further with the unit, and the next session would be on investment function. Till then, keep reading, keep learning, and keep practicing.